In this video, we are going to discuss today's daily Leetcode question. This question name is maximum number of moves in a grid. So you will be given a zero index m cross n matrix, a grid consisting of positive integers. So we need to start with any cell in the first column of the matrix and traverse grid in the following way. From a row in the column, you can move to the row minus 1 column plus 1, like this one from 5 to 4 or 3 to 4 in this direction, and row comma column plus 1 in the rightward directions, and row plus 1 comma column plus 1 in the downward directions. So these three are the possible directions, say 4 to 3, 4 to 9, 4 to 2. So these are the possible directions if and only if the next element such that the value of the cell you move to should be strictly bigger than the value of the current cell. Like that should be an increasing sequence of kind of stuff. So for example, in the first example, you're given this example grid, a vector of vectors, and we need to find out how many steps we can move in the following by following the given rules. So 2 to 4, 4 to 9, 9 to 11 is one possible thing, and 3 to 4, 4 to 9, 9 to 11 the same. So at max we can go to 1, 2, 3 steps. So we'll be returning 3 in the first example. So this is how the question is asked. In the solution for this would be like using implementation of a DFS kind of stuff. So in basically, for example, if we were at the starting position I comma 0 at 0 comma 0, and we need to reach n minus 1 comma n minus 1, then we'll be going towards all the 4 directions. If permitted, we can go to all the 8 directions, and we'll be implementing a check for that the directions, check whether the direction is a valid move or not. In the similar way, we'll be starting with the first elements of the first rows, first column का elements से we will be starting. 2, 5, 3, 10 will be the starting point of the DFS. So after starting point of this here, we will be moving towards the next element in the DFS, such that we will be having only 3 steps, either top or the right or the bottom or the down, such that the next element is less than this. So the simple change in the check matrix check box of a DFS will be suffice in doing this problem. So that's what is implemented in the solution in the C++. So in the solution, first I have been initialized, we'll be having a grid vector of vector. So we need to take the sizes m and n, it's grid comma size, and n is grid comma size of 0. So this is the column size is n and the row size is m. So initializing the answer towards 0. So if the function, this is a lambda functions which is in the C++ setting 14 or above. Only in the C++ 11 we can't find in lambda functions. So in the lambda function, basically it's taking the input as I comma j and as an input, and it would be it would not be returning anything, it's returning a void function. So that's the input and output of the lambda function. In the lambda function we'll be implementing the DFS. So initializing the answer as the max of the current answer and the column till which we have reached. The max answer in this problem would be the number of columns minus 1, because if we look into this thing, so here we have reached from the first row, first column till the last column. So the number answer is 1, 2 and 3. At max we can reach the same. So if the column, if the matrix is n comma m, then that max we can reach is m minus 1. Here I think I've taken m comma n, so at max we can reach is n minus 1 as an answer. So that's here check, if answer is equals to n minus 1 is equals to n minus 1, then we'll be returning, because we have got obtained the max answer already and there is no need to check further anymore. So we'll be stopping the function. In the next thing, we'll be checking all the 3 directions. Smartly we'll be going as it is fixed that we'll be going towards the next column. I have fixed j plus 1, grid k comma j plus 1, grid of I comma j. So here the k is the thing which is variable. K is ranges from I minus 1, I and I plus 1. So there will be possibilities of I to be overbound or lesser bound. So we can check in this following manner. If k, we can take the maximum of I minus 1 or either 0, and k we can take a minimum of I plus 2 and minimum m, because at max we should go to I plus 1 and m minus 1. So in this way we'll be checking from the current element in the array, we'll be checking towards top, left, top, right and bottom ones in the DFS. If it is the value of the corresponding value is greater than the current value, then we will be moving towards DFS and the next thing. And if it is not, we will not doing anything, and we'll be making sure that the current value is equals to 0, such that it should not be in any infinity loops. So it should not stuck in any loop, such that after, as soon as we have reached a particular in element, we'll be making it 0 after traversing it, such that it doesn't stuck in any kind of excessive infinity loops. So that is the main lambda function we implemented here, named DFS. So as I've said earlier, we will be implementing the DFS for the first column, I is equals to 0 to y is less than m. M is the size of the row, and DFS of I comma 0, it's making 0 comma 0, 1 comma 0, 2 comma 0, so on, m minus 1 comma 0. These are, we'll be starting DFS with the first column elements, and we'll be checking whether if there is a possibility of moving towards the next column. We'll be checking towards all kind of possibility. If it is there, then we will be going towards, then we'll be checking that till the ending of the columns, last column. If it is not there, then we'll be returning the answer as soon as possible as it is. At least we can go towards 1, that is for sure. That's why initialize it to 0. If it is the minimum can be here over 0, and that's why it's after submitting it. So this is the code. I already checked it, it's showing now 82 point, before it showed 100% accurate. So that's it. Code for this thing is thank you for watching the video till here. If you hope you like